All right, welcome to another episode. Today we're going to cover acid-base principles. So I'm just going to get right into it. Number one, so the first thing you want to do when approaching an acid-base problem is check the pH. That is by and large number one. Acidemia is defined as less than 7.35. So anything less than 7.35, you know that you're in an acidosis type state. I'm just going to start throwing things up here. So steps. One, let's check the pH. Second, let's say that we have a low pH, below 7.35. Let's say 7.32. So we've identified we were in an acidosis state. Next thing we want to do is check the bicarb. Let's check the bicarb because automatically, if we have a low bicarb and we're in an acidotic state, we know we're dealing with a metabolic acidosis. Okay, so that puts us in this range right here, and I'm just going to write what these individually mean. Low bicarb acidosis, metabolic acidosis right away. Up here, a respiratory acidosis, by definition, is increase in CO2 concentration. Likewise, respiratory alkalosis is going to be a decrease in CO2, and metabolic alkalosis, of course, will be an increase in bicarb. So the first thing I want to also point out is anytime we're dealing with a metabolic problem, it's bicarb. Anytime we're dealing with a CO2 problem, it's respiratory. Okay, so those are two rules. CO2 problem equals respiratory, bicarb problem. It's metabolic. All right, so two principles right up front. And I want you also to notice on this summary chart over here that anytime there's an increase, whether it be CO2 or bicarb or vice versa, decrease in either or, the correct compensation goes in the same direction. So in other words, if we have an increase in our CO2, we should expect an increase in our bicarb as a compensation mechanism. Another important principle to understand is that if the primary problem is respiratory, then you have to change the concentration of bicarb in the blood, and there's two ways to change bicarb. The first way is through the buffering system, which is not very effective in the blood. The main way that our body adjusts the concentration of bicarb is through the kidneys, and so the kidneys take days to fix bicarb. So I'll just put HCO3 compensation equals days, and we'll see why this matters later. All right, so I'm just going to kind of follow this chart and we'll talk about each one. So we've already defined a respiratory acidosis as an increase in CO2 and a compensatory mechanism of an increase in HCO3 or bicarb. So anytime that we have an increase in bicarb, if we're correcting for a respiratory problem, we need to account for either acute or chronic changes. So you'll notice that it's only in correcting for the respiratory issues where you need acute and chronic formulas, because again, there's two mechanisms by which our body fixes respiratory acid-base abnormalities, whereas there's only one mechanism that our body has to correct changes in the bicarb level, which would be either through hypoventilation or hyperventilation. And of course, we know that our metabolic acidoses, the compensatory mechanism comes with Kussmaul breathing sometimes, or uh, rapid breathing here, increase in respiration. Whereas the compensation for a metabolic alkalosis would be to decrease the rate of breathing. Okay.